This experiment models the industrial catalytic cracking of long-chain alkanes and shows that some of the products have shorter chains than the starting material and that some are alkenes. They have carbon-carbon double bonds. The experiment is carried out in a boiling tube, and you need to start by putting some mineral wool, not cotton wool, into the bottom of the tube. The initial source of alkanes is liquid paraffin, which has about 20 carbons in its chain length. Use a dropping pipette to add liquid paraffin so that it soaks into the mineral wool. You'll need about 2 centimetre cubed. Just help that to soak in a bit. And just invert it to check if there's any excess, and if there is, remove it using a pipette. You don't want to get paraffin all the way down the inside of the tube if you can avoid it. You put that into the clamp and clamp it right near the mouth of the tube. Next, you're going to put some catalyst into the tube, and we're using pumice stone. But you can also use pieces of broken plant pot. Both of these are silica based, and they mimic the silica and alumina based catalysts that are used in industry. Now you want this tilted, but not so much so that all your catalyst falls to the bottom. This has got quite an open structure, which gives you a large surface area for the reaction to take place on. You attach a bung with a delivery tube to the mouth of your boiling tube. Have ready prepared a bowl of water with about 6 test tubes also filled with water and some bungs. Next, you need an assistant who could possibly be a competent student, although actually I often do this experiment with 2 students and don't get too involved myself at all. And what you're going to do is to heat using a roaring Bunsen flame, and the hottest part of the flame, which is just beyond the blue cone, and you're going to heat the pumice stone. As you do so, some gas will escape, and your assistant needs to collect the gas in a test tube. You want to get the pumice stone good and hot before you go any further. Once you've been heating for about 10 seconds, then you can flick across and just briefly heat your paraffin soaked in the mineral wool. Then go back and keep the catalyst hot. The whole time, keep the catalyst hot and then just flick across to start the paraffin evaporating. You want to heat the pumice stone for about 10 seconds for every second that you're heating your paraffin. It is important to keep the boiling tube and its contents hot. If it is allowed to cool, water may be sucked back into the boiling tube and it can cause the boiling tube to crack. It's vital to watch the delivery tube for signs of suckback. If this seems to be starting, the solution is to continue to heat the boiling tube with the hottest part of the flame just beyond the blue cone, and to remove the whole thing from the water. It is tempting to push the Bunsen closer to the boiling tube or to remove the heat, both of which will increase suckback. And you can see there are some water drops coming up the tube, and if I just keep heating those, then they should come out. Continue until 6 test tubes of gas have been collected. Okay, when you come to the end and you need to remove it from the water and stop heating, it's really important that you remove from the water first and carry on heating for a moment. When you're happy that there's no water in the tube, you can stop heating, but I wouldn't turn off the Bunsen burner until you're convinced that everything has stopped. Then you need to test the gases. The first two you can discard because they will just be air from your boiling tube. Okay, the third one you can pass around the class and they can have a gentle smell, and it should smell something like camping gas, which is a mixture of propane and butane. The fourth one you can attempt to ignite to prove that you have made a flammable gas. To the fifth tube you can add a few drops of bromine water, which is just bromine dissolved in water. And shake it up, and you can see that the bromine goes colourless. This shows the presence of an alkene or a carbon-carbon double bond.